Welcome everybody to my title and talk partially zoneless performance tuning without Big Bang Refactoring. I did the whole presentation together with my colleague Jeff Cross. He's unfortunately not here, but you can see his pics. And I always, when I do this presentation, have to do announce a big thanks to him because he put so much effort in my title slide. What will I talk today? I guess you know Ivy is shipped since a couple of years now. They still do some tweakings, but they pitched always a lot of cool terms. Component state management, pair component change detection, non-blocking rendering. Nowadays, Twitter talks a lot about fine-grained reactivity and fully zoneless applications. Well, today I want to present you code snippets, examples, and a library that will enable you to do all that stuff already today. To start with some topics, I want to first mention the library that I use. The library is named RX Angular. It has a couple of sub-packages, and it focuses on performance and developer experience. If you like it, you should definitely go on Twitter. There is a star button. Try if the star button works. If not, let me know. And now I want to directly dive into the part that I believe is hardest to fix in Angular. It is runtime performance. And if you want to optimize runtime performance, you should understand a little bit technical things. For example, you should understand what is a frame drop and what is a bad long task in your application, because your goal is obviously to get rid of those frame drops, of those long tasks. If you look at that picture, it's a picture of the performance tab from Chrome DevTools, you will see a couple of highlighted areas here. I highlighted long tasks with one. You see a task has this red area and a red small triangle that marks a specific task as bad, as too long. And at the very bottom in the corner, you see the summarization of all long tasks. So you basically see the sum of how many milliseconds your user interface was frozen, was blocked, and the user could not interact with it. If you understand that, you can try to get rid of those long tasks in your Angular applications. And the easiest way to do this is to get rid of Zone.js. Well, it's not that easy, but it will have the biggest impact. Let's have a real-life application. I work on a lot of big projects. I do a lot of performance tuning there, and this is a really nice example where we took an application, partially zoneless, so only the screen that was interacted with was taken zoneless. And as you can see, Angular natively produces a huge amount of blocking tasks. The user interface was constantly frozen, and it was very, very hard for the user to give him a good experience. We removed zone for that specific type of view, and if you look at the bottom chart, you will see there is nearly not a single frame drop, not a single blocking task, and this is only possible because we don't rely on zone and on this top-down rendering. I will pitch a little bit of estimates for you. We refactored a lot of applications, and this is what our first impression was a couple of years ago when we tried to do that. If you have a small pet project, obviously you can go zoneless. Very easy. There is nearly no effort. If you start from the very beginning, if you have your scope small, if you exclude a lot of third-party libraries, you should not have problems to go zoneless. If you have a production app and you code it from scratch, it is also okayish the effort. You will have to take care of some third-party scripts, of some rendering problems. You will also take care that change detection is not always triggering, but it is doable. What was not doable for us a couple of years ago is taking an existing project and going fully zoneless. You will die. The effort is brutal, and I believe, same as big migration projects from AngularJS to Angular, they will never end. This is at least our experience from multiple years. So we tried to fix that, and we tried to provide a migration path to zoneless. We tried to work on tools that help you to take only parts of your application zoneless and keep the rest as it is, so you don't have this huge amount of effort when you try to implement those optimizations. Let me quickly introduce myself. My name is Michael Hladky. Hladky is very hard to pronounce, read, write, so I suggest we stick with Michael or Michael. And I run a company that focuses on performance optimizations, architectural reviews and optimizations, especially in Angular, and the performance part we do in pretty much any framework. Okay, we need tools. I told you that we worked on tools to bring our applications more performance, and I mentioned it again at the beginning, the tool's called Rx Angular, and I will present to you two different packages today, the state package and the template package, and you will understand why they were so essential and why I created, for example, the state package at the very, very beginning. Again, the star button should work. You can try it out. Let's understand change detection first. Before we optimize the change detection, we should understand how does it work at the moment. I will have three topics. I will introduce you to the component tree, the concept of how your components in Angular are organized and linked to each other. I will demonstrate to you what dirty marking means, like the process of dirty marking and how it influences the amount of re-evaluations of templates. And then I will show you how rendering itself works and how the DOM updates get really applied and you see pixel changing. Let's start with the component tree. And this is one of our demo applications. We use that application to implement basically all our findings, and we also use that application to battle Angular against all other frameworks, because this very application is also implemented in React, Vue, Svelte, and whatnot. And it's a good example repository to also do comparison, not only tricks. If you look at that picture, you see different areas, and I marked a set of components here. We have a side menu item component, we have movies, movie tiles, the star rating component, a small widget at the very top of your page. It's here, it's mirrored, I forget it all the time. And if you take that picture in a little bit more technical way, it looks like this. The blue box at the very top is called application reference. It is a service, and this service holds a reference to your app component, and your app component is the most upper component that holds all other children below him. And then you have the whole application. You have the sidebar, then menu items, the movie, the star rating component, the movie card, and all other things that I used in that application. It's a tree structure. Within that tree structure, we need to figure out where a change got applied and how I can update a specific part of this tree. So what Angular does when I click a button in my component, regardless, by the way, if I update anything or not, it will happen always because of zone. Angular marks a specific part as dirty from the very component you interacted until the very top to the app component. And in parallel to this, there is another process triggered, Zone.js. Zone.js patched all your browser APIs. Zone.js also patched your event listeners. And therefore, if you click the button, in parallel to the dirty marking process, Zone.js will also wait for a very little moment, and then it will execute re-rendering of your application. Zone.js is linked with your application reference, and the application reference service calls a method that is called tick. And if you call this application ref tick method, you will re-render the whole application. You will go to any template and re-evaluate the template bindings. And after that process, you see a lot of dark green components here. To be more specific, not a lot, just 3. But you can see that those 3 components were dirty marked, re-rendered, and the rest was not re-rendered because this application here is already with change detection on push. So all my examples start from a very optimized Angular application to demonstrate that even very optimized applications and change detection and push and all of that stuff is not really bringing the performance boost that we need. But this is how rendering works. I click a button, I mark the path as dirty, Zone kicks in and re-evaluates all the template bindings. I click the button, bottom-up dirty marking, top-down rendering. And this bottom-up, top-down approach is very, very inefficient. Why is it so inefficient? Because it relies on Zone.js, and Zone.js had all these different API patches and all these interferences, and it basically makes it impossible for us to update a very specific part of our application without re-rendering the rest. I will quickly show you how this works in comparison to other frameworks. So on the right side, you see that pretty much any other framework has explicit state management, and only Angular relies on that concept of zone, and you really see that this process is decoupled from the rest. So even if I introduce a state change, it is not in the same flow, it is a parallel flow, and it is very unintuitive to think about that. I have a couple of more examples. Here you see that Zone.js patches every browser API, and therefore it is able to realize when a button is clicked, when something updates, when a timer is called, when a promise is fired. And how does Zone do that? Basically, it takes the original method or function of all your browser APIs that are asynchronous and patches them. It takes the original method, creates its own method that mirrors all the inputs and outputs of that original method. Then it sneaks in custom code. In this example, I sneaked in a console log that logs patched. And then it executes the original function. So this is more or less how API patching works. It's a pretty interesting concept, but unfortunately, it does not bring a lot of benefit to us in terms of performance. If you want to know more, I don't want to dive into too much detail with Zone.js and API patches. You can read it up. I will share my slides, and I have a scary full list of all APIs that are patched. For now, I guess this subset is good enough for us to understand that a lot of pieces in Angular will trigger this process. The last piece in my application ref, I have this zone on microtask empty. I can subscribe to that event, and whenever it fires, I call application ref tick. This is basically technically the underlying concept that we need to keep in mind when we want to understand what changes we introduced. Of course, I have some demos, and here in concepts, I can show you, if I zoom in a little bit, that we have numbers here and here. And if I interact with one of those components, and I zoom out a little bit, we see that all the numbers from the bottom to the very top update. And also, if you have a look at this part here, also other components that are not really related to that path will update because they are on that path of dirty marking and they have no change detection on push. And this is a big problem because in real-life applications, normally you have some leaks and there is always a component that is not on push. In worst case, it is your app component. Okay, now I will start with our tools that we shipped, and I quickly check the time. The first thing that I was working on and researching, it is, I guess, 4 years ago, was explicit state management. Explicit state management is needed because I, as a developer, need a way to tell Angular what exactly changed and where. At the moment, we don't have that mechanism. We have Zone.js that runs its magic and just re-evaluates everything, and we don't really know where the change is. But this is the first piece we worked on, and this was extremely necessary to do our first experiments with zoneless applications. So if you want to go zoneless, you definitely need to think about explicit state management. React, Vue, Svelte, they have it ever since, and they don't really understand our struggles in the Angular framework, I would say. At least this is my experience when I talk with other developers about their change detection mechanisms. Our state management tool has basically a set of different APIs, one set that helps you to interact imperatively with state changes, one set of methods that helps you to interact reactively with state changes, and those methods are very, very helpful for us to boost the performance. So I have a reactive and an imperative layer, and our state management service basically unites those things in a very nice and elegant way. There is an example of APIs, but I want to quickly show you how this would look in a real-life application, and I hope that I can manage the live coding here. So let's start with a very simple example. Let's start with selecting some state changes from your global state management from wherever. And if you do that and you really want to have a performant change set stream, let's call it like this, you need to implement a couple of different things. First of all, you don't want to render if there is an undefined value, right? In Angular, it could happen very easily due to the async pipe and other stuff that you receive undefined, and you would evaluate change detection with a value that is not here. We filtered it out, and by filtering out undefineds, we really gain a very, very critical thing. We gain laziness wherever we consume that stream, and I want to show you that I consume that stream later in the template, so basically we have lazy templates. Second thing, I only want to render real changes. I don't want to render a value that goes from 2 to 2. I only want to render new values. Then, of course, I'm interested in a specific state piece, for example, the movies property. So I plug that out, and then I have a share replay mechanism below it that I don't have to execute all that logic again and again and again for every subscriber. I basically can share that. If you look at it, let me comment it out. The only interesting part for us is the mapper. This is what we really care. This is our developer code. The rest is boilerplate, unnecessary, repetitive code. So let me fix that, and let me show you how our API can handle that. There is a select method, and in the select, and in the select method, I basically could place my operator, and the select method automatically arranges the pipes around this past operator. So I don't need to retype that. Of course, if I only want to plug out one single property and nothing else, it is still a lot of code to write. Map, plug, return. That sucks. So what we did is we made a small shortcut, and we now can provide the property name as string. And in this case, we save a lot of lines of code, and we get out exactly this property and the change set with all mentioned optimizations. So this is one small example of how we run change detection and state management in a component. Second one, and this is, I guess, our big game changer, we released that API also, I guess, 2.5 or 3 years ago. I want to pitch to you the Connect API. So whenever you code with something asynchronous, a promise, a observable, you will end up in cluttery code where you stop your asynchronous, your reactive programming, you set a value somewhere, and then you try to go back to this reactive or asynchronous programming. And this is the place in your applications where you will introduce memory leaks, problems, bugs, flickery state, and all of that things happen just because there is no good interopt between sync and async things in Angular. So what we did to do that, let me quickly tell you that if you have a change, you need to subscribe to the change, you need to store the subscription, you need to unsubscribe when a component gets destroyed, you need maybe to plug out the old state, and then you can set that stuff in your state again. So what we did, we basically introduced the Connect API. So I can basically say connect, and connect receives a observable that will get subscribed to automatically, and all the changes that will come out of that observable will get updated automatically to a specific property. In our state object, we want to update the movies property, and I can then pass the observable that maintains all my changes of the movies property as a second parameter, and this one-liner here is basically everything that I need to take observable changes from whatever it is and update the property in my state management. I can get rid of all of this code, and I don't need the ng on destroy lifecycle hook at all. A very nice one-liner and the last state management demo that I wanted to pitch to you today. It's pretty cool, huh? You save a lot of lines, and this was so far a little bit of performance and a lot of developer experience, because all the boilerplate of your code is now gone. Next, I want to take that managed state, I want to forward the values that I showed you how to manage now to the template, and I want to render those values in my template. And if we look at a normal Angular architecture, we see that if we forward the values, pass it through our components, child components, whatever, and then want to update just one single snippet of HTML, it over-renders quite a lot. Everything that is yellow is unnecessary change detected, unnecessary executed, and will take away time, or to be more specific, user experience from your users. And I guess what we all want to is get love from our users. So this is very bad, to get love from our users. The first thing that we introduced also quite a while ago was the push pipe. The push pipe with that architecture enabled us to focus on only one single component. And now the surface of over-rendering is very small. It only over-renders the very template of this component that was not updated, but not the rest of the component tree. With this in mind, we took it one step further, and we introduced a directive that in this case is called the Rxlet directive, but we shipped 3 to 4 other directives to 1 minute. And I will take 3 minutes from Sam. It's okay. Is okay, Sam? Thanks. So now I need to speed up. This component, this structural directive basically helps us to re-render only the very snippet that received an update. And if you compare those two, you see that on the one end you re-render a lot of stuff, on the other end you only re-render what you really need. And I could demo now a lot of things and refactor a lot of stuff, but I want to save everybody's time and quickly do the most essential demos. I show you that the left button, this is what Angular would do normally, or the push pipe would do normally, re-evaluates every single piece in this template here, because all the numbers that you see change when I click the button. See, all numbers change. If I click this button here, we realize that only the numbers of this very template snippet change. So this is the technical proof that we can update as minimum as possible. Next thing that I want to change you. Our architecture, together with state, enables us to pass observables directly in input bindings. What does this mean to us? This is a set of nested components. Here at the bottom, I have the important value that I need to update. And if I click that button, you see every single component re-renders the very last one too, and of course also our top component re-renders if we click that button. You see the numbers change, okay? That's the default case. With our application, with our architectural pitch, where we pass observables directly and combine it with Rx state, and I click that button, nothing happens, but only the very number here at the bottom that needs to get updated changes. It's already a very nice improvement, and in combination with our Rxlet or other structural directives, this will really bring a brutal performance boost. But that's not all. We have more features. You can read up all our features online. I just want to quickly demo to you, I guess, one of the most fanciest demos ever. I can do viewport priority. So I can have a tick here, and this tick updates a number constantly, and we see that the DOM here is changing whenever my number changes. So what if you have templates, components that are not visible on the screen? Would you want to update them? I guess no, because the user will not have any benefit. So what we did here is we implemented basically a way to change this, the change detection strategy and mechanism. And if I move out a div from the viewport, you see that there is no update present at the moment. Nothing happens. And if I move that stuff in again, we see the changes are now executed again. So I can definitely only update stuff that is at the moment visible to the user, and this again brings a brutal performance boost. I have 1 minute left, so the last thing that I want to pitch is most fanciest, I guess, and a game changer. It's chunked rendering or non-blocking rendering in Angular. At the very top, you see what Angular does. It just executes work. It doesn't really care how long your task is. It doesn't really care if the user wants to interact with your application. It just blocks the screen. And maybe you realized how a blocking screen feels. It's not really good. Huh? At the bottom, we see the same work executed with our new render strategies. And our render strategies are basically aware of the frame budget, and they will avoid long blocking tasks. We did researches. This is the NG4, for example. It blocks a lot. We rewrote everything with our strategies, left original, right our rewrite. And this is the outcome. So our NG4, it's called RX4, implements all the necessary learnings that we did. And if you compare that with the previous one, you see it's less than a third of the work executed, and it is brutally fast. Last demo, then I go. I'm sorry that you started to clap, but I have to interrupt it. Look, if I navigate to native, it freezes. There is this gray area that basically stays for a while, and then my change goes in. I can also add a little bit more items, then we see it better. The freeze will be longer. I click, frozen, navigation. So with our technique, I click and I immediately navigate there. And the cool part is I can click and click back, and I will interrupt the rendering, and I will drop all the stuff that was not rendered already. If I do that with native, it is frozen. It will not work. So we can basically interrupt any single mechanism that runs with change detection in Angular. People getting nervous. I feel that. I also get nervous, so let me finish that up. I don't go fully zoneless because you can just use RX Angular and it will work out of the box. Star it. My name is Michael. These are the picks from Jeff Cross. Goodbye.